We've got Lukas, who I've already mentioned. Bjorn had a place of honour, but he's wandering off. And then Rafael over here. Rafael's an enthusiast. He's been around. For anyone who's been on Facebook, etc., probably has seen his name. He's normally ranting about something. And he's here to video record it all. So, shall we move on to the next stuff?
Yeah.
Okay. Hardware. Key thing about Rotorflight straight on. There are a lot of different options here for hardware. And I kind of alluded to this beforehand. You've got the ability to use just about any transmitter system you want. There's no requirement to feel that there's any mandatory thing which says you have to change. If you're a Biriba user, go for it. It will work. What changes for you is the level of integration and ability that you can do stuff. There are certain systems which are just better integrated. Why are they better integrated? Because in the end, the developers are using those systems. So in my case, I'm a FreeSky user. I've done countless hours on FreeSky radios, Ethos Suite, or RF Suite, I should actually get the name right. RF Suite is fantastic, but absolutely, if you want to use EdgeTX and have similar stuff, it doesn't matter from the Rotorflight point of view. We're very platform agnostic. One of the lesser known things is you can actually use a Spectrum radio. And the radios which have a system called CMS built into it, you can use that to configure Rotorflight. So there's nothing stopping you if you're a Spectrum user saying, I don't have to go buy a new radio. Flight controller-wise, well, there are a variety of brands. The ones you probably know the most about. Radio Master, a very big player, but FreeSky, also quite a big player. The ones which jump out after that, you've got FlyDragon. FlyDragon you don't see so much of anymore. They've focused more on speed controllers. They do have a FlyRadar speed controller these days. And then if you really want, there's a variety of others. You can get quadcopter controllers, you can get all sorts of things. And it's really up to you how you choose to build it. But the best experience by far, get either the Radio Master or FreeSky. Those two, they're fully integrated, they've been designed and built with us as a team, with the manufacturers, and as a result, we guarantee you they work well. It's really your choice, and I think as you can see on this screenshot here, well, we have a variety of protocols that can be used. It's your choice again. We integrate to a lot of different speed controllers. I think just about every single major player is now catered, but again to varying degrees. So, for example, you could plug in your YGE speed controller and you would get forward programming. What forward programming is the ability for you to use your radio to set up your speed controller. So you no longer need to use your desktop software if you wanted to reverse the speed controller. So you're using the speed controller's governor, you can do that directly from your radio. The options there, Contronic, we actually is just about ready for full forward programming too. That might just make Rotorflight 2.3. But we have a number of them, and it varies. Best, XT-Fly, fantastic integration. ZTW, much the same. Scorpion, superb. Hobbywing's pretty good, as long as you're on Hobbywing 5. Version 4 Hobbywing doesn't have forward programming, but telemetry works fine.
Maybe that's a good point of skipping to the next slide. So in theory, we're supporting a lot of different hardware options, but there are others that work better. So we put together a slide of which, if you ask us, what should I buy to get into this? These are some of the components that Rob is talking about. So these are, so I would buy either one of these radios. If you have one, it's fine already.
Yeah.
But in terms of flyable systems, the latest ones are the Radio Master Nexus X and XR, so with integrated receiver or without, and the FreeSky 007, and one of these speed controllers. So they have mostly forward programming. This one is currently just about there, but all the others, and very good telemetry support, and they have proven to work very reliably.
Correct, and I think what's also, apparent and not apparent here, we're showing obviously a number of these FreeSky radios. There's multiple different ones you can buy from this. They all work just as well. On the Radio Master front, which also integrated, you've got the newer, faster CPU stuff. Some of you may or may not, that's actually a jumper.
Yeah, jumper T15.
So again, EdgeTX as a platform runs on FlySky Paladin, it runs on Jumper, it runs on RadioMaster. You've got a lot of choice. It's really, again, everything that supports, you know, for the best integrations at the end of the day, you either want to go Ethos or EdgeTX. Those are the two which are going to give you the best value for money and the best experience. Yes?
Is it okay to ask a question?
If you want, fire away.
Yeah. You talk a lot about this forward programming, and that it makes very good sense. What about the actual speed controlling? Is that in all cases better using the, for instance, Nexus built-in governor?
So we have a section on that we'll get to.
Sorry?
Yeah.
Perfect. Okay, so again, we've got a lot of choices, and I would like to think we can support just about any of the systems you might find out there. There will be some edge cases. I think Spectrum Avian is a little bit...
it works somehow, but it will be giving you a bit of a headache.
Yeah, so there's better and worse, and do your research. In the end, what would I recommend? If you wanted to stick totally open source, go AM32, works great. XT-Fly, superb. FlyRotor, that's a hidden gem. FlyRotor is an incredible speed controller, it works so well. And in fact, it's actually the only speed controller where the developers have worked actively with the Rotorflight project to integrate. So it works incredibly well and well worth it. And again, flight controllers are great. You can jump to the next one and see what I'm dealing with. Okay.
Let's put that somewhere here. So this is the setup we're going to demo in here. Just a very basic setup with some of the components we mentioned on the slide before. And this is going to be part of the second part of the presentation. Rob is going to demo the setup on this. And it's using an XT-Fly 85 amps ESC, RadioMaster Nexus XR, and just some generic servos. You could basically use any. And
then on top of that, I think you're connecting with, is it your Ethos radio?
Yeah, that's mine.
So there's a little bit of a full mix of stuff here that's available, and it will give you a bit of a sense. Again, choice is yours. Okay, so I'm hoping this is not all in German.
We switch it to English. So shall we go through the slides and then do the setup afterwards?
You can. Yeah, let's do that.
Yeah, okay.
You can tell how prepared I am.
Okay. So let's move on. Let's do the setup demo in the second section. So there were some questions about the speed controllers. So we're using Rotorflight governor in this setup. So which means that we configured the ESC to a wing or external governor mode, which means the internal governor of the ESC is deactivated, and we're using Rotorflight governor. And to get that working, you need to set up your gear ratio so that your Rotorflight knows which gear ratio it has, because you're essentially setting up the main rotor RPM. And you also need to set up the main motor pole count. So it depends on how many magnets you got in your motor. So that's the basic setup to be done for making this work.
I think what's worth clarifying here is the reason for this is that if Rotorflight can calculate from these ratios what your head speed is and your tail speed, it can improve the filtering. Because rather than doing a wide band and saying, I'm just trying to filter noise, it can say, I know the noise is at these positions, I'll just filter those positions. And the result is that it means that the CPU on the flight controller can work half as hard to do the same job. But if, on the other hand, you were not, say you just didn't know what your gear ratio was, or you had a speed controller, you just had no idea, you can actually just use your speed controller, put a throttle value through, and use what's called dynamic filtering, where it does just listen to the most noisy channels. But you want to get that a little bit more, get the gear ratio.
So that's the next one. So next thing is setting this whole thing up to make forward programming and also Rotorflight governor work. So to get this working, you also need telemetry integration to get the most out of it, I would say, to get the battery state estimation.
And that's speed controller telemetry you're referring to.
Yeah, speed controller telemetry. And for getting this work, you need to set up the PWM wire, the RPM wire, of course, and additionally, you need the telemetry output of the ESC connected to your flyby system, and you need to configure it accordingly. So here we're using XDFly, so you set that up. Yeah.
I think what's important here again is I wish we could turn around and tell you use these settings for the speed controller. Broadly we can, but every speed controller is slightly different. If, for example, you were using a Hobbywing 4, you would probably not want bidirectional control because Hobbywing 4 doesn't support that. So it's, it's a little bit of what am I talking to and a little bit of research you would have to do at that point to say this is the type of speed controller I have. What are the settings I'm going to put on? There's a lot of help out there about that already, and clearly on the Facebook groups and the Discord groups. Ask the question, you'll be told, put these in. It's not always plain sailing in that, and it does result in a lot of confusion. You don't need a degree in electronics, but it does help if you have a little bit of understanding about what red, black, and yellow are.
The bidirectional is just saying the speed controller talks back to the ESC. Is that how?
In order to do forward programming, you need to have bidirectional. So what that means is you've got a two-way link. Whereas if it's non-bidirectional, you've got literally, there's just the receiver, or the speed controller is sending the telemetry, and we can listen to it, we can say, thank you, we've got it, but there's nothing more you're going to do.
So it won't hurt whether it's on or left on?
No, not at all. The reality is it's only going to matter to you if you care about forward programming. It's really, that's what it comes down to. The vast majority of these systems will work in receiver, just non-bidirectional mode quite happily. And in fact, that is actually a confusion point that occurs sometimes as people get their telemetry working and they say, my forward programming is not working. It's like, well, you're only listening. So it's just one of those things, and every speed controller is different.
Rob, by the way, I think we got an old version of the presentation, but yeah, we have to see what's coming next.
That's the one you sent me last night.
Yeah, it looked different for me, but nevertheless, let's go on. So we already talked about that, and we're at the moment in the process of refactoring Governor et al. So it looks a bit different now, and it's going to be what you will be getting in the next release. So, but in general, this is what we were talking about. You shift off from having Governor in your ESC back to closing the loop to Rotorflight. So it's transmitting the RPM signal and getting a PWM signal back. So, and what's essentially the difference there is that your Governor inside your ESC, it would have to react. So whenever you apply more collective, your RPMs are going to get lowered a little by the additional resistance by the air, and then your Governor has to react. If you use Rotorflight Governor, we have the opportunity of using that knowledge that there is a radio signal coming in, and we can make the RPMs more stable by reacting to the RPM signal, not reacting to the RPM signal, but rather that
proactive reaction, which says we know your collective has gone full because you're doing a punch up. The Governor's already on Rotorflight saying, as your stick movement was going up, just saying fire and more power. So the result is you get a really locked-in Governor.
And I think the great feature about this is also that you can enter your head speed directly from the radio or via configurator. You can just set up for every profile a full head speed, and it's going to run on that head speed.
Yeah. Which again then lends value to having the radio systems which can allow you to configure this, because you go to the field and you can adjust your settings and say, oh, it just needs a little bit more because now that I'm punching out, my tail's going. The great thing is put the Governor on, adjust the head speed. Thank you very much.
There's a Governor 1 and a Governor 2. Are we saying this is on Governor 1?
So
that has changed.
It's changed. It has changed. The new Governor is completely different. But broadly, the Governor mode 1 and mode 2 from the previous systems more about listening to things like your voltage. So one of the options, I think Governor mode 2 on the old one by memory, allowed you to listen to the voltage of your pack, and if your pack was sagging, it could respond in relation to that. But the new Governor is vastly superior.
So it's just one governor on the new governor.
It's one governor, but I would say it's vastly superior, but there's more buttons to twiddle.
But essentially it is in a way that you enable governor, you either set it to electric or nitro, that's the thing, and then you have a throttle type which controls how you're going to spool up.
Yeah.
And that's basically it.
And
so,
there are also a number of new options, and I'd highly recommend you watch the video by Archie over in America, Archie RC. Some of you might have seen it already. He's really gone into detail on that, but particularly for the nitro stuff. There's a lot of advanced options you can get into where you can do function curves, where you can literally design the entire curve. You can, you know, it's designed essentially. I don't fly nitro, so I'm not the best person to speak on it. But it really does cater for it very well. You'll also notice that within the context of this, we've got this little bar graph thing going on, and there's actually another page which is not shown now, but one of the biggest aggravations Rotorflight has had is people struggling to arm their helis. Because I'm sure you've had it, it's like, I just can't arm. Well, we now have a little graph which will actually show you the positions. We try to take the guesswork out. Yes.
I think in some of my ESCs, if you switch off governor in ESC, there's still some ramps. That it will not go from 0 to 100 throttle instantly.
So it depends. Yeah, it depends on.
In this case, you need to.
Yeah. So the speed control. So I'm going to move up this way. I'm going to lighten my eye. Yeah. Some of the speed controllers can be a little bit problematic with external governors. Hobbywing is actually a classic example of that. Is they work best if you have the external heli mode. And the reason being is that the way their speed controller system works is if you put an external governor on, you say, okay, let's start up. It just goes, boom, there's power, and then you get this big jerk on the ground and it's horrible. Whereas if you use the external heli mode, you get a nice slow spooler. The problem is you've got this little bit of interference going on because there's a point at which the speed controller has to hand over to the governor. And that's, on Hobbywing, I think it's around about 40% by memory. It's round about that value, and after that, so you've got the speed controller's going, I'm spinning you up 40%. It's like, okay, now what? And then Rotorflight goes, oh, I'll take it. So you can get...
But normally that slow spool up is not an issue because it's okay for powering up the motor to target RPM, but within that governor range, it's only slight adjustments. So it doesn't cause any problems usually. Yeah,
it doesn't cause you a problem in flight in any regard, and you'll normally find that the governor's kicked in, and it's a configurable value. You can set when the Rotorflight governor engages. So if you happen to have a real oddball of a speed controller that wanted to kick in at 80%, well, you could do that. Wouldn't suggest it, but you could.
Okay, so then let's move on. So that's just a brief overview of what we're going to talk about in the second part of the session. So we're really trying to focus on only the essentials. So giving you a quick rundown of every setting that needs to be done, and only that, and not touch all the other stuff, but that can be done, but doesn't have to be done. Because we're trying to get more pilots involved into Rotorflight, and if you're not a pro expert pilot or having some exotic setup, you don't care about 80% of the parameters. The defaults are fine, but the issue is what needs to be changed, and that's not obvious at the current stage.
I think I would strongly recommend don't overthink. Heli pilots love to overthink, I don't know why, but Rotorflight really is a lot simpler than the interface would make you think. It's you know, and I think this is broadly so. I've got 17 helis at home, and I've loaded black box. Never. They're all tuned. They all fly beautifully. I don't use black box. I've got no interest in it. You do not need it as a sport pilot. If you want to eke out that 10-15% extra and you're a pro 3D pilot, go for it. You know, you will do it. I guarantee you a heli will fly better for it. But if you're a typical sport pilot, you gain nothing from it. You know, if you sit down and you look at the purists telling you you must measure your servo movement, you know, get it protracted. I've never done it. You know, I'm a competent pilot, I'm a club instructor. I don't do that. I don't measure my tail, I eyeball it. because just like you're using Beast X when it's no harder. So again, don't overthink it. I think the lesson to take away from this is that what you have within the Rotorflight dev team are a bunch of very clever people who are very technically pure, and they are 100% correct. If you want the best flying heli, calibrate your servo. I'm happy if it's in 90% okay flying heli. So take that away as a lesson. Don't make your life harder than you need to.
Okay, so then next thing is questions we keep on getting is how do I get my radio to work with Rotorflight and how do I install the scripts? So we want to show it here for Ethos, for FreeSky radios, because we have
well, we're all FreeSky pilots.
That's one thing, and we have improved the way of installing the scripts in the past few weeks.
It's literally, I think, well, this came as Lukas showed me, oh, look what I've written. And then I took it and I said, that's a good idea, I made it better.
Yeah, that's essentially it. So the
that's
way,
open source.
The way it works right now is you have an updater for exactly those scripts. You just download it and launch it, plug in your radio, and hit start update.
Yep.
And that's essentially it.
And yeah, you can't really tell on the screen over here, but you've actually got a stable version, too close to the speaker, a snapshot version and a master version. Those are options available to you within the updater. And stable would put you onto Rotorflight 2.2. It's, from an Ethos point of view, that's ancient because you're getting a really old version of the software. It's what was released 12 months ago. Snapshot is a version which we consider, it's stable, it's good enough to use, report back bugs. Master is bleeding edge. You know, now the reason I have master on there is, for me, from the suite point of view, is I have so many people, in fact, I got tired of trying to help people get the latest software on, because trying to tell them to go to GitHub and download stuff is just too hard. So doing this means everyone who does testing, they can say, okay, I'll use master, but accept the risk. You might get what I coded last night, and it's not very good. You know, it could happen. And it does happen, whereas snapshot is stable.
Yeah, what else is there to do? So, of course, once you got the scripts on the radio, you need to enable them.
Yeah.
You need to discover your sensors. It's the same for HTX and Ethos.
So there is a slight difference here I'm just going to get to. Is on Ethos, we have a background task that runs. HTX has the little taskbar widget. It's a similar sort of idea, but there's a difference in how the radios work, which means we have to do it in a different way. But essentially what that's about is kind of, imagine a background worker, which is saying, I'm going to listen, if you're using ELRS, for example, I'm going to listen and decode the telemetry for you. So that's what that background task is about. And with an Ethos, it does a similar thing for the ELRS telemetry if you want to use it. It does a whole more like the adjustment functions, it will play the sounds out for you, you know, if you use adjustment functions, it's a whole more advanced topic. So it's basically just a background worker communicating with the flight controller and telling you, I'm alive, I'm not alive, you know, does the logging, that sort of stuff.
Yeah, essentially, it is the background, the foundation for displaying your data on your dashboard, for example.
Yeah, and essentially everything else that you use within certainly our relatives. The truth is, I haven't used an HTX install 2 years maybe, so I'm not an expert on the HTX stuff. So if you want to ask me questions on that, there's probably other guys at the event who know it a lot better than I do on that side. But certainly on the Ethos front, we have a dashboard. The dashboard is fully themable. You get 3 different flight modes, which is pre-flight, in-flight, post-flight. So what happens is as soon as your heli spools up, the dashboard will switch to an in-flight mode. The idea behind that is if you do bother to look at your screen, well actually you can't look at lots of detail. So it's a case of I'm going to show you voltage and fuel. You know, you can configure these options, you can choose different themes, it's all available to you. And then finally you reach post-flight, which is when you spool down, and that's going to show you results like your minimum and maximum, you know, RPM and current voltage. Yeah. At a glance, statistics that are useful to you. Yeah. Then essentially you were getting to discovering sensors. Okay. if you're trying to get running, nothing will work if you don't have sensors. It's as simple as that. So the background worker, which is running the background task, requires the sensors to be there. For example, you have RSSI on there. If I don't have an RSSI signal, then you are not connected. You're not plugged in, so I don't know you exist. So you have to do a discover sensors. And you might have to do that more than once, because if you later on go and say, oh, I want to add this sensor, you're going to have to go back into Ethos and discover that sensor. That's not Rotorflight's problem, that's Ethos's problem. But that's exactly the same. HTX is the same process.
Yeah.
Yeah. Yeah. That's great. Next one.
Yeah.
Okay. Obviously on Suite, what we've also got, and it's mirrored very similar sort of stuff under HTX. We go into a bit more detail on Ethos, largely driven by the fact that we have a much more powerful CPU. Until recently, we've had more CPU power. And what that means is we have a much more visual display and far more context-sensitive help. So for example, on Ethos, if you clicked on to say the P50, when you selected that, it will actually give you context-sensitive help and tell you what that P-value is for. You've also got the question mark at the top, which gives you this is what you do on this page. But again, this is because in the end, I've got many megs of RAM to play with under Ethos, and the average HTX rating I think is 128K. There's only so much you can do on it. So that there are differences as a result.
So, and then in theory, you could even configure your entire heli now from the radio.
Yeah.
But I think what's going to matter for you as a pilot is not doing that. You will be using the Rotorflight configurator. What's going to matter for you is these three menus. So changing your PIDs, changing your rates.
PIDs, rates, governor.
And your governor.
Those are the key things. And in fact, as Lukas already said, you can now, under Ethos, configure your flight controller 100% from the radio. You do not need a computer. I wrote the software and I'll use the computer. It's as simple as that, because it's quicker to use the computer, it's easier, I've got a big screen, I've got a mouse, I'm not tapping through lots of little tiny screens. So, I think what's key on that is to understand, it is fantastic you can do it, but a computer is going to make your life a lot easier if you've got one, because why fight if you don't have to? And of course, you can also use Android to do that. There's an Android app. If you happen to have an Android tablet, you could use that and run the full configurator software on that, no issue. At the field, this is what matters. Yeah, I went off on a tangent, didn't I? Did I go on a tangent? I think I did. Now, you'll also notice we've got a screenshot there of rates, because Lukas has been taking screenshots from the latest one, which is the new Rotorflight rate system. So Rotorflight 2.3, the two big changes are the governor and the rates. Now, the reason for changing the rates is just to start a process of avoiding confusion. Rotorflight came from Betaflight, and Betaflight, for whatever reason, had actual KISS, I don't know, and there's like 5 different rate systems or something. And each and every single one of them works completely differently, and they're all a mess. They make no sense to anyone. Certainly not from the heli world. They probably made sense to quadcopter people, but not for helis.
Not for helis, that's the point.
Yeah, so what we've done is introduce the new Rotorflight rate system. The end goal here is that by the time Rotorflight 2.4 comes out, we'll drop the old ones, so that people have a year to migrate themselves over. I can tell you straight off the bat, the default settings are fantastic. They just feel so nice. It really is, And out the box, they also come tuned more for us, a non-3D pilot, because that has also been a problem, because there's so many 3D pilots who've been involved in Rotorflight. The default rates traditionally have always been excessively high, and your sport pilots have come along and gone, oh my god, I can't do anything. So they're tuned to a much more sensible level now.
We've got too many pro pilots on the team, so
that's exactly what happened. Yeah, we had every pro pilot a year ago was giving us input onto what the best settings were. We put them in, and then an end user got them in and went, it's too much. Right.
Yeah, so I think that's about it about the presentation. We're jumping into
an actual setup.
Yeah.
Cool.
So this is just some information. If you got any questions, join us on Discord. So feel free to post your questions there. I think that's the main channel to get your questions answered. Yeah, and Rob is now going to set up a heli live, and you're also, you can ask questions if you want to.
Yeah, I'm also wondering, can you all hear me without this? Because it's going to be a bit tricky holding a microphone and the computer at the same time. So if you can all hear me, that will make life easy. Otherwise, okay. Rafael will have to be a microphone holder.
Okay, so then, maybe turn it off, Rob.
I can work out how to do that. Okay.
Okay. So, what do you need?
I need my USB lead through into it, and we'll need your radio in just a second. I can actually turn off my heli.
Is it okay?
Yeah, move mine out the way.
Okay.
Okay. So hopefully you guys are all familiar with the Rotorflight configurator. This is actually the new version, which is coming with 2.3. And what we have here, which I'd like to draw your attention to, is we have a lovely new expert mode tick box, which hides many of the options which will confuse you. So if you don't know what you're doing, don't turn expert mode on. You know, it's endless confusion to me, because quite often when I'm debugging, I've forgotten that I've got it off, and then I'm like, I can't find the settings. But they're there, they just hit it. Okay, so where to start? Shall we, first and foremost with Rotorflight, we're going to have to, as step one, get your gyro set up and orientated correctly. It's absolutely critical that you do this. What I would suggest you do, before even plugging it onto your heli, pop your flight controller on the bench, nice and level, plug it in, and we're going to go through and do a setup and calibrate the accelerometer. This is just an internal calibration to the controller that says, I know which way I'm actually orientated, and I know which way level is supposed to be. I would suggest, if you decided to mount your heli flight controller sideways, some people do really weird things and put them at 45 degrees, I don't know why, go do a recalibration of that. It just makes sense to know that you've got the right settings.
And so, it's important for the takeoff detection.
Yes.
It needs to know which direction it is mounted, and also it assumes when you pass certain angles that your heli has taken off. So it's really important to get it right, because otherwise you risk your heli to tip over while spooling up.
Yeah, and we see a lot of people have reported issues of helis tipping over. It's always come down to terrible calibration. You know, and
we had a question.
Yeah.
The question: when you set up the Rotorflight in Europe, after flight to Australia, that's okay or not?
This is. Do you mean if you were to set it up here, calibrate it, and take it? Absolutely fine.
Calibration is no problem.
No, the calibration is the only thing that would matter in that scenario is the magnetometer,
yes.
And in fact, I think it's not actually on by default. I think so. It's irrelevant to you.
But most flight controllers don't even have one, so
yeah,
don't worry.
Yeah, we have them, and the idea is to have it. So I'm just taking my jumper because I'm cooking here in this room. But the idea with the magnetometer comes largely from the Betaflight quad scenario.
Yeah.
And ultimately, it will be beneficial if and when we ever bother to do a GPS return to home functionality. That's where a magnetometer comes in. We don't have immediate plans, and that ultimately we don't have the team available to do it when somebody wants to volunteer. Is anyone here who can code? Then we will get through to that. So calibration, very important. I would advise, if you have set up your heli already, don't go click that reset settings button, because it's only one away from calibrate, and you might wipe all your settings. Okay, so where am I going? Orientation. So if you're using one of the standard flight controllers, and that being your Nexus or your 007, largely your orientation is already sorted out. And what this actually comes down to is the orientation of the gyro chip on the actual PCB. Okay, so Different manufacturers can produce these things completely differently, and just because we detect the gyro doesn't mean we know which direction the gyro is actually installed on the PCB inside the flight controller. If you're using a well-known brand, this is easy. It's done.
It should be fine. The only thing you might need to adjust is your rotation.
Correct.
This depends on how you mounted your flight controller. You can mount in either direction with the ports facing forward or backward.
Yeah.
Depends on your...
Depends completely on the flight controller, and the easiest way to actually do this is if you had your flight controller and you got the screen, and we were to take the heli and tip it up, left, right, down, you can see the screen's moving. You will very quickly realize if the way you've chosen to mount it is going the wrong direction, you might need to do a 180 spin so that it suits your orientation.
So remember, you might need to change this, and the other thing we set up for this heli right now is that we set up telemetry. So because on this setup, the XD Fly ESC is connected to the telemetry port of the Nexus.
Yeah.
So we need to tell this to Rotorflight to be able to pick up the data from this port. So that's the only two settings that were made in here.
Yeah, and again, if you're using a well-known brand, you'll notice it has a port called telemetry.
Yeah.
One of the benefits the manufacturers have with working with the Rotorflight team is that we can then say, actually, we know what port is assigned to telemetry, so we can label it. Whereas if you were a completely unknown flight controller, you wouldn't get the benefit of seeing that's my telemetry port. You would just get, oh, that's UR2. Good luck. And then if you decided to configure your system, well, trial and error. I've been there and done it, and it takes a while of testing each one to find out which one you plugged into.
You can find these labels, exactly these being printed onto the case, onto the shell of the flight system.
All the good, well-integrated ones. Again, 007 and Nexus, it's on the case, you cannot go wrong. So follow your nose, it's obvious. Now, we already have speed controller telemetry on. By default, that's not going to be on. Largely because you might not be on a heli which has speed controller telemetry, so by default it's off. So you might want to turn that on. And it's important to do that because if you were trying to configure telemetry later, you'll go into the speed controller settings and say, I want to configure telemetry. Why is it not working? Well, it doesn't know where to listen. So you're going to have to turn around and plug your telemetry lead in and make sure your port is configured correctly. Very important, serial receiver. Receivers, obviously, without the receiver connected, you can do nothing. It's not going to work at all because your radio won't ever be able to talk to it. So by default, again, well-known manufacturers, it's going to be there. Don't overthink this, it's configured already for you.
Especially if you pick a flight system with built-in receiver, this will be pre-set up.
Configured and done. It's surprising, and it really is surprising. I do a lot of helping people, and you'll be surprised how many people go and change all these settings, and then it's not working, and you go, but it was. But you went and changed it. So it's, again, don't overthink it. It's set up already for you. Okay, I'm going to jump through to the receiver page, and do we actually, I'm hoping you're on the, what model are you on here, Lukas? This is your radio.
Yeah. Should be.
I don't know what your bind is.
Should have been found.
I might have to restart that because that there was sitting at its pre-screen, so it wasn't going to bind until that came up, and then ELRS goes off on its own.
Yeah, I think it's already in the Wi-Fi mode.
Yeah. There we go, connected.
There we go.
Okay, so back to the receiver. So depending on the receiver brand you use, you're going to have a number of different choices. On all of my helis, so I fly with the 007 Free Sky system, but in every single one of them, I have it configured to the ELRS channel order, largely because I do so much testing and development that it favors me to have one that I can use on both. Completely up to you. It is, however, important if you are using ELRS. In fact, it's only ELRS 4 has just come out now, which has changed the ARM sequence, but prior to that, channel 5 had to be your ARM channel. And the channel order became quite important from the Rotorflight point of view for the ELRS users, because if you didn't have the right channel order, people would be plugging ARM on channel 3 and then wondering why, you know, their channel 5 was kind of operating in low resolution mode, because what ELRS does is to try and increase speed, they send less data on those channels, so you lose channel resolution on channel 5. You know, there's advantages and disadvantages to it.
For you as a pilot, this means that you, after setting up the port which connects to your receiver, you need to set up the protocol that matches your receiver, and you need to set up the channel order. So you can apply a preset here or do it individually, but those are the 2 things to get it working. And you can always check by moving the sticks on your radio, and you can see which channel moves in here, or if they move at all.
To follow on from that, if you again bought a 007 or a Nexus, it is pre-configured. It will be on it already. There's a lot of different receiver options you could choose. We're not going to go into how you configure every single type of receiver, because they are all different. They all have different protocols and standards. But rest assured, with a well-known brand, it will just work. So it's not something you have to think about. There are a number of other settings on this page. Some of them matter, some of them don't. A common issue you'll find is if you have a radio that for whatever reason just didn't have sticks that centered very well. You've got this value over here, 1500, which is basically your stick center. And different brands, some brands, I think Futaba centers on 1450 or something, you know, they're all slightly different.
But usually you don't have to.
Usually you don't have to touch it, but if you went to an obscure brand, you might have to touch it. I can't give you the exact answer on that, but if you're running FreeSky or HTX, you're going to be on 1500. Out the box, it will just work. We move into telemetry. It's quite important to get telemetry turned on. By default, telemetry is actually turned off. Largely, again, this is because we have to, within Rotorflight, we cater to the lowest common denominator. And we can't turn telemetry on because we can't assume the person has a telemetry-enabled receiver. So you're going to want to turn telemetry on. There are some systems which, for example, if you were using the FreeSky F-port system, not the F-bus, it's the older F-port, it will not work if you haven't turned telemetry on. So just get into the habit, turn it on. It's as simple as that. You don't need to worry about the sensors. There's a lot of options in here for turning on and off different sensors. You don't need to get flying, that's secondary. You know, the sensors are only going to be used for giving you information like what's my voltage, what's this. The main thing is you've turned telemetry on, because that means that your radio has the ability now to talk with the MSP protocol to the receiver, which it couldn't otherwise do. So if you don't turn that on, it ain't gonna work. And that doesn't matter which system you're using, it's absolutely important. A little trick. How do you know which way your sticks should move? Well, this comes from Betaflight days. Oh, your collector is reversed. What's going on here, Lucas? Are you mode 1?
Yeah. Mode 1 reversed.
Oh, I don't know where I'm going now. There, okay, goes that way with mode 1. But mode 2, it's the other way. It's all sticks to the bottom left, but mode 1, Lucas has confused me. But essentially, if you go all the way to the side in that direction and everything's to the lowest points, your directions are correct. You know, so don't fight it, that's the way it works. It just does. Unless you're running mode 1, clearly. So it's a handy tip there. It will just tell you your orientations are right. What you really, if everything when you're off to the side goes to the left, you know your directions of your controls are lined up on your radio and you can reverse them. Again, by default, both radio systems are actually the correct direction. So you shouldn't have to do this, but it's amazing what people do. They will clone their old heli setup from V-bar and then start building on that, and things end up in a mess. Whereas if you started a clean model, the default settings again will just work. Right, you also have, if you really want, a little preview here, but that's actually just for nothing more than, you know, proving that the system is working. Now, as part of this, I'm going to jump through to probably the next most important thing I would do first off when I'm setting up a heli, and I would be choosing either between my motors or my servos. I tend to do the motors first. You could do it in either order. The reason I do motors first is because I want to get my telemetry working. It's quite important to me to get that going. And because I've already in the preceding step set the port that I'm using for the telemetry, what I would be doing is going through and setting my telemetry protocol to whichever is on. In this case, it's XD-Fly, the wiring's done. You're going to make sure it's on that. And in this case, with XD-Fly, we require half duplex and pin swap because that's what that particular speed controller requires. I would then go through what's sometimes quite an arduous job of gear ratios. So down at the bottom here, we have RPM sensor and the main gear ratios. If you were not using an RPM sensor, say your speed controller didn't have one, it's not an issue. You just can't use RPM filtering because we don't know what the calculations are working out to. If you do have an RPM sensor, 100% use it, it's worth it. Now,
usually you can get these values from the manual of your helicopter.
Yeah, and it's not an exact science as always, because if you bought a second-hand heli, you're going to go, oh, have they changed the pinion? Have they... I've resorted to a black marker and counting each tooth. It happens. Sometimes you have to do that, but at the end of the day, get those gear ratios and get the motor count. There's a little bit of Googling you're going to have to do, find the motor, you know, get the pole count, enter the value, get your gear ratio, get them in. It will save you a lot of trouble later.
And as you can see here, there are always tooltips which give you some information. For example, here it tells you to tell the magnets on your motor to get the pole count. That's pretty. It's
really, so the maths can be done. And without that maths, we don't know what your head speed is. You can often find a symptom of the gear ratio being incorrect or the pole count being incorrect is if you're setting your head speed. So you've got a 450 heli, and you're like, I'm having to get up to 4,000 RPM on my head speed to make this thing hover. It's your gear ratio, your pole count's wrong, because that thing shouldn't be going that high to do that. So it doesn't mean it won't fly, it just means the filtering's doing nothing for you at that point because it doesn't know what the head speed actually is. So one of the things, when I do the speed controller telemetry, what Rotorflight has is at the top here. If I had working, so you can plug it in, it will actually tell you at the top whether you've got voltage, etc. at the top. And this is quite, there you go, straight off, we've got a 4S pack on there, have we? No, 6S, that's running at 16 volts.
No, it's 4S.
Okay, so we haven't configured it yet, fine.
Yeah.
Okay, so what we've got here is immediately, we know we've got working telemetry because we have a voltage coming. Now, I wish it was as simple as saying that was all you had to do, because occasionally you'll hit a funny, is that you have to go to power, and over in power, there is two options for where it sources your battery and voltage power from. And by default, it's on ADC. So you will configure your telemetry and you're going to go, my telemetry is not working, my voltage is not showing why. I guarantee you haven't selected that you're going to use the speed controller telemetry as the source. This actually all makes a whole lot of sense once you think about it. It's like, how does Rotorflight know where the voltage is coming from? It could be coming from the analog digital converter. Some of these systems basically have a little, I know the Fly Dragon has a port on the side, and you can plug up to 6S into that port, and then it will use that. That's what the ADC port is. A lot of quadcopter controllers get their voltage like that. So again, this is about the lowest common denominator. But WhatsApps, as you can see here, we've got a lot of options. We have that we configured to 6S currently, which is actually incorrect. So I'm going to drop that down to 4, which we get that right. We have the new Rotorflight 2.3 version here, and you'll notice we have battery profiles. In the next version of Rotorflight, you can put up to 6 batteries in, or 6 different capacities. So if you, one of these guys who flies, one pack's 2200, the other's 2300, you know, then you've got the option at least of doing this. And you can configure which pack you are using from the Lua scripts or from the irregular adjustment function. So you could put on a switch on the radio that if the switch is in this position, it's this pack. If it's in this position, it's this pack. And then that rolls through and impacts the fuel consumption alerts that you get. So we can then calculate and know what your fuel capacity is.
You don't have to set this
You
up.
don't have to set it up at all.
It's the only convenience of doing that is that it can tell you your remaining battery and give you alerts when you run quickly before
It's
you
a convenience. If you happen to fly and you're happy running on a timer, it's irrelevant to you. But then I would argue that speed controller telemetry at that point is irrelevant to you too, because it doesn't matter to you because you're running a timer. The great thing about this page too is that you can actually see a lot of other sensors. There's also some slightly confusing values which you probably don't need to touch. And in fact, if you're on a well-known brand, you won't be touching them because they are pre-done. This is just an electronic thing. It's a voltage divider, and it wants to know kind of the value of the resistors inside the flight controller really for calculating. I think that's you're better at electronics than me. But it's just working out to know that what a small voltage means when it turns into a big voltage. Because the flight controller doesn't run on the 6S, it actually runs way lower. Now, next step. Motor, yeah?
Question?
Oh, yeah.
The battery capacity, it's already available on the snapshot version?
The snapshot version doesn't have it, but we should have a new snapshot out next week. Yeah, so it's coming, and all of this, if you're an Ethos user already, the latest snapshot fully supports it. If you were on the new snapshot, the second you connect, if you had these battery capacities, it will pop up a prompt and say choose the pack size. Edge doesn't have that yet, but I'm sure it will come by the time we do a release.
Basically, for the battery capacity, we have to put the real capacity of the battery or 80%?
This is the real capacity.
The real.
So it's slightly off topic, but there is something that I get a lot of questions on too, so I'll answer it too in terms of capacity. I know that Offer Schmooley's Lure does this, and I know that Ethos does it. We have what's effectively called smart fuel. And what we're doing is we're taking the capacity of the pack that you've entered here. We're then taking what the speed controller's current sensor is, saying you're using and subtracting it. But on the radio, we then convert that value into a real 100 to 0 scale. And what that actually means is 0 is when you should land. Not that your pack is empty, you're at your 30-odd% power. But it means that your fuel gauge is actually a real gauge as opposed to I've got to land at, well, whatever value you feel you want to land at. In my case, I normally can't concentrate long enough, so I land. But yeah, so we call that on Ethos, we call it smart fuel. I'm not sure what Offer calls it on his, but it will be something similar.
But summarized, it's safe to fly to 0%.
Yeah, absolutely, because that's what the gauge is designed for. Now, you do have some options for cell voltages, minimum, maximum. In 99% of cases, you guys are flying LiPos. You're not going to ever change these values. They're really only there for oddballs. You know, if there's anyone here flying a nickel metal hydride pack on their heli, I doubt there is, but you know, maybe you wanted to change the values. This is one of the strong points and the weak points of open source, is that with open source we get a lot of buttons. And you get to twiddle and play with everything, which is great, but it's also confusing because you've got more options to play with. Okay, so on to servos, I think we should probably go to.
Or the governor, because
Governor.
The motor topic.
Oh, that was me just saving your 4S.
Yeah, that's it.
I'm back. Okay, Governor. Okay, so this is showing the new Rotorflight 2.3 Governor. Do we have anyone here who flies nitros? Oh, I mean, I have to go into this. Okay, so by default, we're configured as an electric governor. You have an option. You can turn your governor off because you just don't care about it and you're using, well, whatever system you fancy having.
Or the ESC governor.
Or the speed controller governor in that case. Or nitro, direct, limit. I actually have no idea what limit's for, but I can tell you what direct is for. I didn't write the code for this, Petri wrote it, but direct essentially is if you were passing the value through from your throttle channel straight through to the motor. You know, and some people do want that, where they... It's very much like what pass-through is, but it's given a more accurate name of direct, which I'm not sure is any more accurate, but
it's for fixed pitch helis. There are some around, especially small ones, and for those you would use that one.
yeah. But in 99% of cases, you're probably going to be on electric, the default, or nitro.
Yeah.
With electric, very straightforward. You've got different types of throttle types: normal, switch, or function. Normal is basically your throttle's going to ramp up because you're going up the full range. If it's a switch, which is actually what I use, is I toggle my switch and it ups the throttle. The end outcome is actually much the same, whichever of those. If you happen to have your throttle on a switch, but it was sending a ramp up, it will still work. It just takes a fraction longer to get there because it ramps up. So there's not a lot in it. You then also have the option function. Function gets into slightly more advanced things, and it starts involving these bypass curves, and it's very much more for nitros. Now, I'm sure you nitro guys will know that sometimes you want to have a situation where you need to adjust your idle to be at a certain range, and well, I'm really not the person. If there's anyone who can speak on nitros, brilliant. But you want to get the idle rates right. It's about that. You can adjust the curve correctly. And again, Archie's video on this goes into so much detail.
I followed Archie's video on this. It's just set up the way. I haven't flown my nitro yet. I've only just set it up, but it's just set up the way Archie shows in the video.
Archie is very, very skilled. He works very closely with the team. I chat to Archie probably every day. He knows this stuff inside out, and if that's how he's setting it up for nitro, trust me, it's the best way. We do also, again, as you saw in the earlier pictures, you've got your off idle on, etc. Now, in the vast majority of cases, if you are flying an electric heli and you are setting up at a governor, you're going to set this to electric. You're going to set it to switch, because I think the vast majority of heli pilots probably with electric don't use where they kind of idle their throttle up to take off. I think most people have probably moved to having a switch these days. Put it to switch,
and keep
off you
all
go.
the defaults.
Everything else default.
Yeah.
Everything will just work. There are a number of different parameters like the auto, the idle, etc. These start getting into advanced features. You don't need to think about them at this point. Now, I am going to mention one aspect is the option called auto. Auto doesn't mean you can't auto if you don't have this setting. What it actually means is the governor says, you've put me into auto rotation mode, so I'm going to apply a very small amount of power to your engine to keep your motor running. So you're getting the ability to practice your autos, for example. So you don't want to risk your £1,000 odd heli. At least you know that you've got a little bit there and your head speed's going to keep going. So that's actually what that's about. You can happily auto just by cutting the power and auto down. It's not an issue. So it's a very particular mode as an aid. The new system has a lot of interesting things. They're slightly more advanced, but you see there's a spool down time, 3 seconds. This is actually fantastic for tiny helis, because if you were running an OMPM2, you could say, I want a 10-second spool down time. That means I've cut my power, and it will slowly bring the power down, and suddenly your M2 feels like a 500, which can auto into land, because actually we're spinning it down slowly. So it's a little bit of trickery, but it's a nice feature to have, and it's kind of cool, because your heli feels floaty when you cut the power. It's kind of like you just got this little bit more. But again, defaults out the box. You don't have to touch them. The only thing you're really going to do, electric, and set your switch. Do that, you've got a heli where the governor is working.
If you're going from 2.21 to 2.3, are we talking about resetting most of things up, everything up, or none of it up?
So I have upgraded all my helis from 2.2 to 2.3 on the same flight controller, and in every single one of them, and I would officially, I would say, do a diff all and do this. I've done a dump all, pasted them all, and continued. Because I have had to go in and reset up the governor using the configurator, because the governor is different. but every other setting has just come across. And when you do that, you're going to get a whole lot of errors being thrown because the old parameters that were there are no longer there. So it's like, oh, I can't do that. I've saved at the end, gone and set it up manually, done.
Yeah, it's actually dump and just check through it.
Yeah, it's... Oh, we've got another question down there. Yeah?
Yep. Maybe a silly one. I don't know. What if you have an ESC which disagrees on what is full throttle and what is actually zero throttle? So reversing the throttle channel, where would you do that? I'm
going to enable expert mode because I believe it's under here somewhere.
Okay.
There are options somewhere, and I haven't used this one in a while. Head speed, cutoff spool. Oh, yeah, sorry, I should actually jump back because actually, so this is what your minimum and maximum throttle is. You're actually going to have to go to your receiver settings, aren't you, for that? Because you've got your minimum and maximum throttle values that you can set for what your... So, when you set up the flight controller, the receiver is talking to the flight controller, then the flight controller is talking. So it's actually, there's a translation that happens. So if I sent a value, for example, of say -1500 to the flight controller receives that and then says, I'm now going to convert that to whatever value I think you should be outputting. So there's a layer between translating. And one of the things here which you got is like the throttle channel with the minimum and the maximum throttle allows you to adjust those endpoints. If you had a speed controller which, say, you couldn't calibrate it using the normal full power, bring the throttle down mode, you can tweak those settings and then the maths behind it will map what your radio does to do it. I think what's key here, you don't go change that on your radio throttle setting because that's the wrong place to do it. You actually want to change it here so that the flight controller is telling you what that setting is.
Calibrating your ESC is also a good way.
Yeah.
Aligning everything, because then you have the endpoints. Otherwise, it can happen that your ESC won't even out because there is a slight amount of throttle applied, at least from the perspective of the ESC.
To calibrate your speed controller is quite straightforward if you know how. And one of the simple options you can do, I can actually demo this. You want to do your battery? So if I go to the configurator in the motor, and I click enable the motor, what I can do now, you unplug there, I can take my throttle lever here, pop it to 100%, and if you plug your speed controller in,
let's wait for the confirmation.
Yeah. Okay, you're in?
Yeah.
And then I'll bring that down, just like doing it on your transmitter, but the radio was not involved in it. So essentially what that process is doing is saying, I'm sending 100% throttle, just like on, calibrate any plane speed controller or anything, it's the same process. You start on 100, you drop it to 0. The difference is you just did it from the Rotorflight configurator, because now Rotorflight has been calibrated to your speed controller. Or should I say rather, it's actually the speed controller has been calibrated to Rotorflight.
Rather than.
Yeah. It's a worthwhile step doing. I will admit I often skip that step because most, if you're using an XD fly or a fly rotor, they just work, they're already right.
I don't know why I got into problems when I tried to set up mine. I think these microseconds over here, motor off, high throttle, low throttle, is there some interlock that you're not allowed to have higher microseconds for max throttle than minimum?
So there are some confusing little things around that.
That's what I got into.
And Rotorflight 2.3 is a lot easier in this regard. We've changed the way it detects that, so you'll find for the next snapshot that comes out, those problems will hopefully be gone.
Okay. Somehow I got through it, but
yeah, you're not the only person. There's been a lot of people have struggled with getting the throttle endpoints right.
Okay.
And I think this is a classic case where you've got developers who knew what they were doing and did everything the way they expected, and it all worked, and they said, yep, this is great. And then the end users didn't know what they were doing, tried to do the same thing, and it doesn't work. It's an iterative process, unfortunately. Okay.
Shall we move on to servos?
Servos, because we do need to watch time. So, I did say this earlier, you do not need to worry about half of the settings on this page. There are a lot of options, geometry corrections, speed, rate, doesn't matter. Okay? What matters is your directions and stopping mechanical binding. Those are the two things that actually matter to you. Now, in this case, Lucas, do you want to steer here? Because I'm going to keep doing the wrong button on this one. So, what's absolutely key here is you want to get your servos moving the correct direction for your swash plate alignment. Now, I'm going to, I believe on this one, is it at the back for your rear servo? Yes, that should be 1, 2, 3 by memory on it. And essentially what I would do in this case is I would raise my collective full up. Okay, so just pop it full up. And then all I'm going to do is go through to my reverse. And I'll find, okay, that one's now going up. Oh, that's the wrong way. There you go, that one went up. And that's the tail. So if you now go up and down, there's a swash plate going up and down. There you go. Sorted the directions out. Wasn't a big issue, basically. Put it full up, at least you've now got that right. I can actually see this swash plate is... How do you fly with that? So, this brings you straight, but I'm going to say that Lucas intentionally put this at a horrible angle for this demo. You're going to have to get your servos centered. Clearly, mechanical is the best, but mechanical doesn't always get you spot on. And we all know why your pinions line up and you can just find it's just not right.
And also for geometries like this one, it's a DFC rotor head, so there are limitations in terms of mechanical adjustment.
Yeah. And what you're going to get down to is setting your center. We've already set the directions, yeah, and a little bit of guesswork here, or if you want, you can enable servo override, and we can actually see which direction. And sometimes what I'll do is I'll say, okay, I've got servo 1, 2, and 3, and I will take servo 3 and I'm going to move that along. Hey, that's looking level to me. Servo 1, which is that back one, feels like it's crikey, that's horribly out.
It is.
Good. And the other one I'm not going to worry too much because I can't see it from this side.
Yeah.
But the principle here, you can see by doing this live adjustment, I've got a value, 1750. Okay. 1750. Okay. It's now completely gone off to 2000. Well, that's because I've got my slider in the wrong position. If I put my slider back to 0, I'm correct. So this is just about centering your servos, and it's not a particularly complicated job. And by and large, those are probably the two key things, your direction plus your servos. You do those two things, you're already 90% there. Beyond that, you're going to want to make sure as a precautionary thing, is this your aileron on this side? Hold on, servo override. You're going to want to make sure, as with any heli, that your swash, I can actually see here that our swash, when I'm pulling elevator, is going the wrong direction. I'm going to correct that elsewhere, because the servos page is not the right place to correct that. What matters is your collective going up, because your collective is going down. Were you down when you went up? Or do you fly backwards?
I fly backwards.
Or did you reverse?
Reverse collective, reverse throttle.
Okay.
Yeah.
Are you from Australia?
I'm not.
I must have done that when you were down. I must have pressed it. Okay. So essentially, that's what's going to matter to you. There are a number of other options, minimum and maximum. In most helis, you're not going to have to touch those. It's ultimately about your mechanical binding. It's to know that when you are at 100% collective that you're not binding. The reality is, even setting that value now can kind of be a little bit redundant because you don't know that you're fully centered. We haven't measured it. I'm not going to go into trying to measure that now exactly. You don't know that your pitch is going up to the correct level yet. So actually setting those values now doesn't really help you that much. But if you know your swash is going the correct way, which we know it now is, oh, there you see, now that's working. Yeah, that was because we were backwards before. So after that, I would be jumping through to the mixer page, which is the next one on the list.
What about the tail?
Oh, I jumped that because I thought you'd all understand it. So tail is exactly the same. Basically, same principle, just set the direction to reverse or not reverse. I wouldn't be caring about geometry correction straight off. And I actually wouldn't be worrying too much even about the minimum and maximum at this point.
And the center?
Yeah, center point, obviously. Find your center point. That's what matters.
So you want a center tail slider?
Depends on your heli. Yeah, I would.
Like zero pitch? Are you looking for zero pitch here? Or?
So I tend personally to always go for zero pitch.
Yeah.
That's my personal view. I can't answer for every heli out there because I've seen some odd ones where you look at the tail slider and you go, my zero pitch and things just don't seem to make sense, but it does once you fly. But typically zero pitch.
The easiest way is to fold both blades and align them.
Yeah.
So that's the way I do it.
Yeah. And that's exactly like any heli controller, same process. Get your direction, continue on from there.
That confused me a little bit. Normally that has to happen a little bit.
Yeah. So
that's for all range gyros.
Yeah.
So we don't care about the limits here. We don't care about limits here.
The only limit I might care about at this point, if I felt inspired to do it at this stage of the setup, is the minimum and maximum on the tail. I tend to not ever do the collective at this point.
Yeah, I'm still talking about the tail.
Yeah, so if you're dealing with the tail, if you're dealing just with the tail, obviously move your servo right to the end, check that you're not binding. You might need to increase or decrease your values over here, and you might need to, if you're not getting enough movement, increase or decrease the scale value.
That's what I find on most, at least on the XL, the 700s, it's just not enough travel.
Yeah, in which case you can up the value to say 600 to start with, and okay, now it's getting the movement. This completely depends on the mechanics of your heli. You know, the default values will work probably 80% of helis out the box, but again, if you happened on your heli to have put the tail servo on one horn notch further out, well, that value is completely different at that point, because mechanically it's different. But again, these are quite, you know, don't overthink these values. They're literally just a number which represents the endpoint. And I think broadly, it's basically just make sure the thing isn't binding. That's the key thing. If it's not binding, you're in the right position. Where I do most of my stuff after that is then going to be the mixer page. So out the box, you probably configured already. Was there a question there? So,
yeah, maybe about the resolution of the servo.
I intentionally left that out because I didn't want to jump into too advanced. So if the default settings will actually be absolutely adequate, okay? But it depends on your heli. If you, for example, your tail was a narrowband tail servo, yes, you're going to have to change the setting. But not every heli's tail servo is a narrowband heli, so it kind of depends on what you're using. And I think, like every flight controller, treat it the same way. Look at your servo and you say, what is it? If your servo manual says you can do 400 hertz, then by all means go change it. But the default's going to be absolutely fine. Yeah, in fact, the vast majority of these days don't require anything bar the defaults. In terms of your mixer, quite key on this page, main rotor direction, probably default because I don't really actually know of anything bar some obscure scale helis which run the other way around. But what does matter is things like aileron control direction, elevator control direction, collective control. Say we've done all of this and we then decided we're mounting the flight controller was the other way around, things like that. You might, or in fact, even like say you were on a heli where the servo in the front here was actually on the other side. The result is that mechanically, even though you've got all your swash plates set up right, you're going to have to tell the mixer to go the right way. Logically, we've done that. The trick here, like with every heli, do your movements. If you find it's going the wrong way, but the right way on there, what you do is you go in and you say, okay, I will change the direction. Because now what that means is when the flight controller is governing the swash plate, not your radio, that actually the directions are going correctly. Does that make sense? I'm trying to explain that in a simple way. But essentially, we know that my sticks are working. I then turn around and I pick up the heli and I go, it's going the wrong way. It's those settings. You need to go change the direction of the mix because when you move that heli, the gyro in the flight controller is now controlling it, not your sticks. So that's the stabilization system and you've got to go change those values.
But you probably need to make sure on the setup tab that you have the correct directions because you may have to adjust the gyro.
You would hope you've already done that in the first step. If you hadn't done that, then you've got a chain of events coming through which will gradually get worse, which is why the first step we did was calibrate your gyro and get your direction right.
That's why you have that little 3D model of the heli, so you can always move it and check if it moves accordingly in the configuration.
You know, and actually
that's why this is like the control, and that's like the sensor part.
Correct. That's yes, the flight controller knows where it's moving. This is the flight controller controlling the swash plate correctly. Because of, you know, and you can see why people get confused, because they'll configure the first one and then not realize to do this, and then actually you've got to get your swash plate still going because it moved right on your first page up here doesn't mean your swash plate's going the right way. That's now a mechanical issue. Okay, so where was I? Mixer. The next things on this page which are quite important are your cyclic calibration and your collective calibration. In the end, this comes down to how far your blades will change. So if you're trying to reach 14 degrees and you move your collector fill up and you say, I've only got 5 degrees, you know, and it's surprising how often the defaults are like that. And again, the defaults are low because if we keep them low, we don't have a mechanical binding when you first plug your heli and you go, boom, it's bound and I burnt my servo out. So we keep the movements very low. I have many helis where these values are well up over 100. So do not be surprised if you're going to be changing those values. Does that make sense? So at its simplest level, if I go, I don't know if you guys can actually see on this here, if I took that value and then I went to my collective and I pushed it up to say 125, see what happened? It jumped straight up. So obviously at this point, what you are doing is you're going to get your angle meter, you're going to make sure that you are centered, which if you've done your servo alignment correctly, and you've then done your mechanical alignment just like with any heli, yes, I'm centered. If you're lucky enough to have the little mark on the center to be centered, brilliant. And then what you're doing, get your angle meter on it and adjust these ratios, the collective calibration and the cyclic, to get the angles you want. This process is identical on any other heli controller. You've got to set the right amount of movement. Go. But don't be surprised if you're going to go to a very high value. I would say that 80% of my helis are probably around about 90, but I've got a few oddballs where I've gone way higher, and normally it's because I chose rubbish servos.
And especially the smaller the heli is, the more strange your values can get. For the very small helis, it can get way beyond 120, so even 150 or something. The geometry is kind of weird on those.
Yeah, and you have a number of other options as you go down the page here. You're generally never going to have to touch any of those values, because if you're going beyond 15 degrees, let's be honest, your heli blades are coming to a stop pretty soon. You know, but maybe you're on a scale heli and you said, I don't want to ever go past 7 degrees. You could put a limit in, and what that will do is basically say that the combined input of collective and cyclic will never exceed a certain value. So it's taking the combination, because remember that if I put my full collective and I've got 15 or say 14 degrees, and I then put full cyclic in, actually I'm going to be beyond that. So the limit is there to say, what is the absolute maximum that I'm prepared on my heli to go to? The defaults that are sitting there of 15 are good defaults. You know, any 3D heli, you plug it on, the default is fine. You don't have to touch it.
Is there a certain cyclic angle you could target? I mean, doesn't this affect the overall gain of the controller?
In terms of the tuning, do you mean?
Yeah.
So, yes, if you are clearly if your blades are moving multiple degrees, it's going to have an impact on your tune. But at least at this point, we're on the ground and we're doing mechanical setup. We haven't flown yet, so we should, in theory, not have tuned it yet.
But you don't go for normally 9-degree cycling or something?
Not the way I fly.
Okay.
Yeah, not the way I fly. I tend to have, basically, I will calibrate my helis that I get 12 degrees on cyclic and 12 degrees on collective, and that's where my happy spot is. Whether or not that's right for you guys, okay, there's a different answer, but that's where I find my helis are tuned like that.
But yes, if you've tuned your heli and you're going to change it afterwards, you have to retune.
So this part of the total gain.
Yeah, and obviously, you change your mechanics, you're going to have to retune. But that retune might only be 1 or 2 points, but it's something you might have to do. So One thing which does come up occasionally, collective geometry correction. A very obscure value, but I'm sure you guys have had before where you put full collective up and you're getting your 14 degrees or whatever you want, and then you put full collective down and you go, why am I only getting 12? And we're all upset because we can't get an even balance. Well, collective...
Archie has a nice video on that.
Yeah. The geometry correction actually helps fix this problem. Because what it does is it basically just moves the gain, the amount it goes in either direction, and I can't tell you if you'd have to go up or down on that value. It depends on the heli and it depends on the mechanics. But you can use that value to raise or lower it to say, okay, when I put it on -10, now I get my 12-12. There's a bit of experimentation to do.
I wanted to tell you to hurry up a bit.
Ooh.
So we have 2 more points to cover. One is assigning the arm switch. That's quite important. And also what to do if your heli is not spooling up.
Okay, so let's first jump to arm switch. Modes. Arm switch. Rotorflight has a modes system which basically takes a channel input and says do something. And there's a whole lot of predefined positions. One of them is arm, and you can see there's a number like angle mode, horizon mode, rescue, etc. What you're really doing here, which is your arm switch on this one. Okay, so you can actually see here, I'm configured to aux1. I can actually set that to auto, toggle my switch, and it found aux1. So I didn't have to go searching for it. And you'll see the red bar moved along. By default, this is going to be sitting probably looking like that. And you're going to go, how do I arm? Well, it is as simple as saying, when my throttle is between those 2 values, I am armed. And it really is just as simple as that.
And you can easily check by looking at the box on the left. If you toggle the switch, it turns gray. If it's turned on, it's
armed. Yeah. It's armed. And there's really nothing complicated about it. I always put a large buffer to it. In truth, you could get this really, really close if you wanted to. But I kind of feel there's, we're not doing anything else in that channel. Know that you've got this big buffer, so if you happen to trim your stick or do something funny, you don't break it. That is the process of doing an arm, and the same process applies to everything else, which I will save that value so we have a valid arm. You had another point you raised there that you said.
Yeah, what to do when the heli is not spooling up. So that's, I think, the
status page. First and foremost, status page tells you a lot. And it's this little thing called MSP and arm switch. So what this is actually telling me, first thing, MSP. MSP is the protocol that is used to configure your flight controller. The fact that it's saying MSP is complaining that my USB port is plugged in. You cannot arm if your USB port is plugged in. It's a safety feature because what we don't want people doing is spinning the heli up on the bench with their blades on, so it's kind of like you've got a very forced step. I can override that on the bench. But you see what it did there? That was because my switch is in the wrong position, so it was saying, I'm not going to allow this. So as soon as I enabled arming, it complained because my switch position was wrong, which was actually the other one, because you'll see there, it won't allow me to arm because my arm switch is in the armed position. So there is a lot of useful information that is available on that screen, and you can use that. There's also a lot of documentation which will tell you what each of those messages mean. On both lures, on Edge and Ethos, they have status pages, and those status pages will actually tell you the same information. Certainly on Ethos, it's actually reflected here where the governor is displayed in the dashboard. I'm actually seeing exactly the same MSP and throttle warning being displayed, telling me there's a problem.
So these are the 3 most common ones, I would say. So throttle, so that popped up just now is when I move my throttle into anything not being 0. So it's going to complain about that because I'm having the throttle applied. So
There are a few other oddballs you'll find which come through. I don't think we really should go into each of those. If you look at the online manuals and things which tell you what the warnings are, they will outline exactly what those are and what the causes are for those. But what's key, look at what that warning says. It tells you what the warning is. Go to the web page. It's on the Rotorflight org site. It will tell you what those warnings are. If you search for arming flags, it will tell you. And you'll notice the beep, that little swash plate wiggle, that confuses a lot of people. That's all about a visual indicator when you're at the field and it does, I'm not going to do it, and it doesn't mean it's broken, it means there's a problem and I'm not going to allow you to go ahead. And then that's going to be time either to use your lure or your configurator to find out what's going on.
Yeah, all those features can be quite annoying, to be honest, and can be some kind of a hurdle sometimes. But we introduced them to make it safe for you as a pilot to use, and not for anybody to get hurt.
Yeah, in the end, safety is probably the most paramount important thing. We would be doing you guys a disservice if we released something which didn't have those safety checks in it. So from our point of view, we have to make it as safe as it can possibly be, that you can't make utterly stupid mistakes. It's a heli, it's dangerous, you could still make a stupid mistake, but if we can protect you as much as we can, we will. Ooh, we got 1 minute.
Yeah.
No, we don't even have 1 minute. We're done. We're done. Oh, okay. I hope we covered, I think we covered a lot of ground there, and probably nowhere near enough. And I think there were 2 other things I wanted to flag up. I know that Rafael wanted me to mention there's a raffle going on downstairs for a FrSky radio. Speak to him, he's got stuff.
And you can also meet us at the FrSky
I'll be
booth.
down at the booth. If you've got any technical questions, want them asked, I'm around. I'm here today and tomorrow, so just drop past and shout if you want to see more on what these do. We've got, come down and see the Engo glasses if you haven't seen them already. Engo glasses are a new feature for Ethos. You can get real-time telemetry straight to your glasses. You get a HUD on your display. So if you want to see them, come see it. It's all pretty cool stuff.
Can I grab the microphone?
You can grab the microphone. I don't know if it's on, but grab it.
We are going to have a giveaway of FrSky radio. So if you want to have the numbers, you can fetch here with me. And the giveaway is going to be 4 today. So you need to record it. So if you want the number, just speak with me. And that's it. If you have any questions, we are going to be in the FrSky booth. So you can just come and meet us and we can continue.
Yeah, building a battery.
Thank you very much, everyone, for joining today.
I need a